What if we could predict nature's most destructive storms? Days, even weeks in advance, with unprecedented accuracy? What if artificial intelligence could save countless lives and billions in economic damage from cyclones, hurricanes, and typhoons? Well, thanks to DeepMind, that future is closer than you think. A top story on Hacker News recently highlighted DeepMind's WeatherNext model, which has achieved a monumental breakthrough in cyclone forecasting. And today, we're diving into exactly what that means. Hey everyone, and welcome back to the channel. Prepare to have your minds blown. Because DeepMind, Google's powerhouse AI research lab, has just announced a game-changer. WeatherNext. This isn't just another incremental improvement. This is a paradigm shift in how we understand and anticipate the terrifying power of tropical storms for decades. Predicting the genesis, track, and intensity of cyclones has been one of meteorology's most complex challenges. Traditional methods rely on incredibly sophisticated physics-based models run on supercomputers. Complex equations simulating atmospheric conditions, ocean temperatures, and wind shear. While these models have improved dramatically over the years, they still have limitations, especially regarding lead time and the rapid intensification of storms. Enter DeepMind's WeatherNext. This isn't a physics simulator. It's an AI that learns from vast amounts of historical weather data, satellite imagery, radar readings, and atmospheric sensor information. Think of it as an incredibly intelligent pattern recognition engine. Instead of crunching physics equations from scratch every time, WeatherNext has learned the asterisk patterns of how cyclones form and evolve by observing countless past storms. It identifies subtle atmospheric cues that precede cyclone formation, tracks their development, and predicts their trajectory and intensity, often faster and with greater precision than traditional methods, especially when it comes to those crucial longer-range forecasts. The core of this breakthrough lies in DeepMind's advanced deep learning techniques, likely employing sophisticated graph neural networks or similar architectures that excel at understanding complex, interconnected systems like the Earth's atmosphere. These neural networks can process immense datasets, literally petabytes of weather information, at speeds unimaginable for human analysis. Imagine a computer screen displaying a live, global weather map, with a projected hurricane path glowing brightly, showing its likely course days in advance. That's the power we're talking about. So, what's the real-world impact? It's enormous, truly life-saving. When a community receives a longer lead time for an approaching cyclone, it means more time for effective evacuations. Coastal cities can initiate emergency protocols earlier, securing infrastructure, allocating resources, and deploying first responders. For residents, it means more time to protect their homes, pack essential supplies, and get to safety. This doesn't just reduce fatalities. It significantly lessens injuries, trauma, and the chaos that typically accompanies last-minute preparations. We're talking about the difference between a panicked exodus and an organized, systematic response. Beyond human lives, the economic implications are staggering. Cyclones cause billions, sometimes hundreds of billions, in damage annually. Better forecasting means industries can prepare, shipping routes can be diverted, agricultural sectors can harvest crops or secure livestock. Insurance companies can better assess risks. Power grids can plan shutdowns and restoration more efficiently. The savings, both direct and indirect, could be astronomical. A digital map on a large monitor showing projected economic impact overlaid with the storm's path perfectly illustrates this. This isn't to say traditional meteorology is obsolete. Far from it. DeepMind's WeatherNext is designed to complement and enhance existing systems, not replace them. Imagine meteorologists in a control room, analyzing not just one, but multiple forecast models, traditional physics-based simulations, and now, the AI-driven insights from WeatherNext. The synergy between these approaches will lead to more robust, reliable, and comprehensive forecasts, providing a clearer, more confident picture of an impending storm. We see scientists in a modern office environment, collaborating, looking at screens displaying complex data visualizations. One of the most exciting aspects of WeatherNext is its potential to improve predictions of rapid intensification, when a tropical storm quickly escalates into a major hurricane. These events are notoriously difficult to predict and can catch communities off guard, turning a manageable situation into a catastrophic one in a matter of hours. If WeatherNext can consistently provide earlier warnings for rapid intensification, it would be a monumental step forward in disaster preparedness. Of course, like all powerful technologies, there are challenges. The reliability of AI models is heavily dependent on the quality and quantity of data they're trained on. Ensuring global access to high-quality weather data, particularly from regions with sparse observational networks, will be crucial for WeatherNext's widespread success. Furthermore, integrating such a sophisticated AI into existing national and international weather agencies requires significant collaboration, infrastructure upgrades, and trust building. And, as always with AI, transparency and explainability are key. Understanding why the AI makes certain predictions helps build confidence and allows human experts to critically evaluate its outputs. Looking ahead, WeatherNext represents just the beginning of AI's potential in addressing global challenges like climate change and extreme weather. As our climate continues to warm, we're likely to see more frequent and intense weather events. Tools like WeatherNext become not just beneficial, but absolutely essential for adaptation and resilience.